Hello, today I'm going to explain implicit differentiation. So let's say I've got the following equation. Let's say I've got 3x squared plus 4y cubed equals 7, where both x and y are functions, and I'm looking to find dy dx. So I'm looking for dy dx of this here, 3x squared plus 4y cubed equals 7. Okay, so I will differentiate each term in the brackets in respect to x. So I'll carry this out right now. So 3x squared, that will be as normal because it's the x variable. So that will become 6x now plus, now for the y term, and we start out by doing it normally. So normal power rule, so that would be just 12y squared, but on the end of it, we will multiply by dy dx. So this is just for what you do if you're differentiating a function that is different to the one you're doing it in respect of. So I'll give a different example. Let's say we have, let's say I've got 4x plus 3a squared, just say it equals 1, and we're doing that dy dx. So it would just be 4 plus, and then it would be 6a dA on dx. So it's a function you're differentiating it. So the a on the top, that's the function you're differentiating. On the bottom is the one you're doing it in respect of. Okay, so I'll finish off this main one. So 6x plus 12y squared dy dx, that will equal 0 because the derivative of a constant is always 0. And now all I have to do is isolate dy dx, and I've got my answer. So I will take 6x from both sides, so I will get 12y squared dy on dx equals to negative 6x, and now I simply divide by 12y squared and I've got my answer. So dy on dx equals negative 6x over 12y squared. Okay, I'll do another example. I'm looking to find dy dx of this following equation. 3x times by y to the power of 4 plus y squared equals 12. So I'm doing dy dx for this. So this first term, 3x times by y to the power of 4, this is a product of two functions. So the 3x is a function and the y to the power of 4 is a different function. So this means that we're going to have to use the product rule. So we differentiate the first term, so 3, then we keep the second term the same, y to the power of 4, plus, and now we keep the first term the same, 3x. Now we differentiate the second term, so times by 4y cubed, and multiply that by dy on dx. And now we differentiate the second function, second term. That will be 2y dy on dx, and 12 is a constant, so equals 0. So now, the first thing to be recognized here is there is multiple terms that have dy dx in them. So there is this term here, there is also this term here. So eventually, we're gonna have to take a factor of dy dx at the front, which will be a bit more clear in a moment. But first thing I'm gonna do is I'm gonna take 3y to the power of 4 from both sides. So I'll write out what I'm keeping on this side. Dy dx plus 2y dy dx, that equals minus 3y to the power of 4. And now I'll take my factor, so dy dx out the front, and the things dy dx is being multiplied by in the bracket, so 3x 4y cubed, that goes in the bracket, plus 2y, and then equals minus 3y to the power of 4. And now all I do is I divide by the things in the bracket, and then I've got my answer. So dy on dx equals minus 3y to the power of 4 all over 3x 4y cubed plus 2y. Let's do a different example. So let's have sine of y plus x times by, let's say, cosine of 4y squared. Let's put brackets around that. Equals 4x y. Okay. And I'm trying to find dy dx again. Okay, let's do this. So the derivative of sine is cosine. So it will be cosine of y. And again, because it's the y variable and we're differentiating in respect to the x variable, we multiply by dy dx. Now the second term, this is a product rule. So we have a function just x. We have a different function cosine for y squared. So we differentiate the first term, so that's 1, times by the derivative of, times by the second term. So just cosine 4y squared, that one doesn't change yet, plus, now the first term stays the same, x, times by the derivative of the second term, so that would be minus sine of 4y squared times the derivative of inside the bracket, so that would be 8y, and again, because it's the y variable, we multiply by dy dx, and then all this equals another product rule. Okay, so then that is, so 4x is differentiated, so 4, y stays the same, plus 4x stays the same, and the derivative of y is dy dx. Okay, so now I will put everything that's got dy dx in it on the left side, and terms that don't have dy dx in it can be moved to the right side. Okay, so let's have a look at each term. So this one has dy dx. Actually, I'll put that in blue. The second term does not have dy dx. This third term does have dy dx. This term equals 4y, it does not, and this one it does. So let's rearrange this thing. So cosine of y dy dx can stay on the left side. We'll come back to the ones in red. Okay, I will simplify this term over here. So that is minus x sine, actually put it all at the front, minus x 8y, sure, let's put dy dx there as well, times by sine of 4y squared. So that can stay here. And then the dy dx term on the right hand side, the 4y dy dx, that can come over. So let's do that. Well, sorry, that is 4x dy dx. My apologies. Okay, yep, that's right. So that can come over. And now I will keep the 4y there. And then this cosine 4y squared, that can move over. Take the cosine of 4y squared. And now I will factor out the dy dx's, and we're almost there. So dy dx cosine y, take x 8y sine 4y squared, take 4x equals negative 4y, take cosine 4y squared. Okay, so now I would divide by the things in the bracket, and then I've got my answer, which will take too long to write, but that'd be it. So all this here, that would go there. Alright, thank you.